The fourth question of the exercise, it asks about the twin primes. They're defining them that twin primes are the pairs of prime numbers that differ by two integers. So we need to list the twin prime pairs up to 100. In order to do that, we have to write all the numbers from 2 to 100. Why are we not taking a start from 1? Because 1 is neither prime number nor a composite, so therefore we take a start from 2. We will be expressing numbers from 2 to 100. Then we will be finding our prime numbers. Once we find our prime numbers, then we will be next finding our twin primes. So this method of finding the prime numbers, it was introduced by a Greek mathematician, and this method is called as the Sieve of Eratosthenes. So let's imply all the steps that were being introduced by this Greek mathematician. So the very first is to write all the numbers from 2 to 100. Then circle 2 and cross out all the multiples of 2 that are greater than 2. So in here, 2 being the prime number, I have circled it in 2, and then we cross all the multiples of 2. It means that we exclude all the multiples of 2. So in orange, all the numbers that are being encircled in orange, they are crossed out. So 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 24, 26, 28, 30, so on till 100. All of these numbers, or that are the multiples of 2, they are being crossed. Then we take 3 being the prime number. Again, all the multiples of 3, that the numbers that are being circled in green color, they are being crossed out, and all these multiples till 100. 99 is the multiple of 3, so you see I have circled it and we have crossed it. Then we do the same with 5 and 7. We take 5, all the multiples of 5, like 5 into 1 is equal to 5, 5 into 2 is equal to 10, 5 into 3 is equal to 15. They are all being circled or crossed in purple color in order for you to differentiate them. Then 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. So all the multiples of 5 are crossed out. Then this multiples of 7, we first circle the 7, and then we cross out the multiples of 7. 7 into 1 is equal to 7. You have to keep in mind that we are not crossing out 2, 3, 5, and 7, but they're multiples only. So in here, the multiples of 7 are 14, 21, then 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, and 98. So once we did that, the numbers that remain are all prime numbers. So the ones that are remaining, they are being circled in black color. So we are having 2, 3, 5, and 7, the starting prime numbers, and then we are having 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 53, 59, 61, 67, 71, 73, 83, 89, and 97. So all these numbers, that are left after crossing out the multiples of 2, 3, 5 and 7. We have enlisted them all in black here. Now each two numbers we see what is the gap between them, like how many integers gap they have between them. 2 and 3 there is no gap, you can say. 3 and 5, so there is two differ of two integers, so therefore this is one pair. 5 and 7, again there is a difference of two integers, so this makes another pair. 7, 8, 9, 10, 11, so three numbers, therefore 7 and 11 cannot be twin pairs. Then 11, we are having 11, 12, 13, so again two integer difference, so this is another pair. Then 13 and 17, 13, 14, 15, 16, since the gap is, or they differ by three integers, therefore this cannot be considered as twin prime. Then we are having 17 and 19. As you can see in here, again there is a gap of two integers or two numbers, so two prime numbers, so therefore this is another pair. Then we are having 19 and 23. The gap is bigger, or the difference is bigger. 23 and 29, again the difference is bigger than two numbers. Then 29 and 31, this is a difference of two numbers, so therefore this is the next twin prime, or yes, twin prime. 37 and 41, again the difference is bigger than two numbers, so this cannot be. Then we move to the next one. 41 and 43, again there is a difference of two, so this is our next twin primes. Then 43 to 47 we check, again the gap is bigger than 2, so this cannot be. Then we move to the 47 and 53, again the gap is bigger. Then 53 and 59, gap is bigger. 59 and 61, the gap of only 2, so this is our next prime, twin prime. 61 to 67, again the difference is bigger. 67 to 71, the difference is bigger. 71 to 73, so on. Each number we check. 71 and 73 is also our twin prime. 83, 89 and 97, if we compare 83 with 89, the gap is bigger. If we compare 89 with 97, again the gap is bigger, more than two numbers or two prime numbers, therefore the last twin prime is 71 and 73. So finding the twin pair, we compare the prime with the next prime number. If the difference is 2, they form a pair which is called as the twin pair. So this is how we imply the sieve of Eratosthenes method to find our prime numbers, and then as mentioned in the question, we can enlist our twin primes, or the pair of a twin prime. That's all for now. I hope it's all clear. Happy learning!